This is for the 5 worksheet. And I'm gonna do this handy little trick of making a box to get myself a square angle, because otherwise I'll screw it up. So we know that we have 2 forces of tension that are not equal. And I think the angle here is given with the ceiling. Harnesses, the 2 cables are, oh, it doesn't matter. It doesn't matter. What matters is that we know that these angles are not the same. So they form a right angle with one another, but they are not the same. So we have theta 1 and theta 2. Theta 1 does not equal theta 2. Okay, now here's where I have to admit I feel stupid every single time. So there's our giant dog. I always feel stupid because I can't. So I think FT1 is going to be the larger force of tension. Again, it doesn't matter what you've labeled them. You'll see the numbers. It always makes sense to me once I have numbers. So what we know is that FT1 is 2 times FT2. One force of tension is twice the other. Now that does not mean that the angles are twice the other. So let me ask you this. Which axis gives us something to figure out pieces of? X or Y? Why? Because we've got mass gravity. We know that force of gravity equals mass gravity. So we know that we can do a little bit of sort of working around FT2y, FT2x, and we can actually do a sum of forces on the y. We know that, is it Zorba the Mastiff is hanging still. There's no acceleration, so sum of forces on the y equals 0. All the forces up minus all the forces down. Force up is FT1 on the y. Force of tension 2 on the y would also be up minus the force of gravity. Can we write an expression for FT2 on the y? Of course we can. Don't be silly. Shoot, I forgot to hit the record button, so poor Brady. No, not Brady, Duncan. Dustin! Good Lord. Who let me out of my box this morning? Okay, if we had our angles, everything would be just gravy at this point. Sadly we don't. Well, wait, can we get this down to just FT2 and just a single angle? Are you ready for a little bit of trigonometric, either ecstasy or pain, depending on your perspective? I see a few of you squaring your shoulders bravely. Let me hit record again. So we've established this. Sine theta 1 is A over C. Yeah? Sine theta 2 is B over C. Cosine theta 1, let me get rid of these, is B over C. Cosine theta 2 is A over C. Oh, look at that. Looky, looky, looky. I'll never, ever give you anything like this on a test, I promise you. It's a mental exercise. I want you to get good and flexible at working through these. So, therefore, sine theta 1 is equal to cosine theta 2. So we can actually say for this 2ft2 cosine theta 2 plus ft2 sine theta 2 equals mg. Okay, we still need defined theta 2 or theta 1. You can come at it from either direction. So here's where it's going to, I mean, that actually wasn't that painful, was it? Okay. We actually have another axis. That other axis is the x-axis, and we can do sum of forces on the x. Is this thing moving left or right? Is it? No. It's hanging there in space. So acceleration is still 0, and that's all the forces right minus all the forces left, which is ft, what would be 2 on the x minus ft 1 on the x, and since they equal 0, ft2x equals ft1x. Well, there are a couple things we know. So we know that the total force of tension on each of these has to be equal, but it doesn't have to be equally distributed. How many of you got this far already? No? Okay. So we know, looking up here, whoops, and looking at our angles, this is going to be cosines. So ft2 cosine theta 2 equals ft1 cosine theta 1. We know that 2 times ft2 equals ft1. So ft2 cosine theta 2 equals 2. Nope, do I have that backwards? Yes, I do. Oh, no, I don't. Okay. 2 ft2 cosine theta 1. All right. What can I do here? Well, what if I divide let's see, hold on. At this point, I can factor something out. What can I factor out? It's going to seem counterintuitive. Whoa. Is that legal? Yeah, it is. So now I'm down to the cosine of theta 2 is equal to 2 times the cosine of theta 1. So if only I could get this down to a single trig function and a single angle. Let's go back to this bit of work. And actually, this bit of work. I'm going to sit down for this. All right, so what do we know about cosine know about theta 1? Oh, I know what we know about cosine of theta 1 and cosine of theta 2. They're equal to one another's sines. So we can do, let's see, sine divided by cosine equals tangent, or vice versa? Hold on. Sine divided by cosine. Opposite over hypotenuse divided by adjacent over hypotenuse equals opposite over adjacent. So sine divided by cosine. All right. If we, I'm going to shrink this. So if we use what we did here to say that the cosine of theta 2 is actually equal to the sine of theta 1, we have sine theta 1 divided by cosine theta 1 equals 2. Huh. Guess what? Now we have tan theta 1 equals 2. Can we figure out theta 1 from here? Inverse tan function of 2 equals theta 1. What's theta 1? Can you now find theta 2? Sure, because 63 point whatever plus theta 2 equals 90. Shut up, Moser. Just give me the angle. Let me go. That's theta 1. You've got theta 2. So now, if you come up to this expression, you should be able to find your force of tension. And you'll find 1, and then you know the other is twice that. Make sense? Should I shut up and let you work a little bit?